Welcome to another edition of the Sim Racing Garage. I'm Barry Rowland. In this episode, we'll be documenting the build process for the ProSimu T1000 M5 4DOF motion platform. This is part 1, called The Build, of a 2-part series covering the full review of this system. Part 2, which will be called The Setup, will continue on with getting the ProSimu system online and using it for sim racing duties. So, let's get to it. So we're going to start our assembly process by using this frame, and there's actually 2 of these frames. They're identical, and these are going to be what they're calling the base 1 in the instructions. So this will have feet on it, and sitting on the bottom is supporting everything else. Now you'll see this frame construction here. First off, this is a 2mm thick steel all the way around. This, at least everywhere that I could get a measurement, that's what it was. And you'll see we've got a lot of holes in here. And these holes are for access to nuts so that we can fasten things to the top. This is actually the bottom, obviously. And we can get in here and get a ratchet with an extension in there and tighten things down and attach them as we need to. And obviously we'll see that as the process goes on. Now we have a hole here, over here, and over here that we're going to actually be putting some feet on. So let's take a look at what we get here. This comes in a bag of bolts. So we've got a lot of bolts and some feet and things in here, and as you can see, it's actually labeled, if you can read that there, base 1, right? So it's got feet and all the attaching hardware we're going to need for the base 1, and this is going to also have a swivel point on it that we're going to be using this big 10mm bolt. Well, let's get, oh, there you go. That's easy enough. This guy. And this is going to be attaching the pivot point for the frame that sits on top. So you can see it's pretty massive there, which is nice. The frame is powder coated all the way around, as all the parts are. It actually is a pretty nice finish on here. I like that. We've got some good welds on here. It's not really easy to show you these welds. I'll show you the welds actually closer. We got down the bottom and the top, of course, going all the way around this frame assembly. But I have other pieces that are smaller. We can take a look at the quality of the welds that we're getting here, and they're all pretty consistent so far from what I've seen. And this is a massive piece here. It is very heavy. It's 22 pounds 5 ounces. For the rest of the world, that would be 10.12 kilos. Yeah, that's it. So yeah, it's a substantial piece of metal here that we're going to be sitting down. We're going to have 2 of these, and they're going to be connected by some spreaders, but we'll get to that as we continue the build. So what I'm going to do now is just get to putting these feet on, and we're going to have, again, 3 on each side, and we'll take a closer look at the feet. They've got this rubber piece underneath. It's a very hard rubber, but it is rubber. And of course, then we have the bolts coming out the middle of the foot right here, so it's going to attach to the bottom, and we can adjust the height of this by spinning this back and forth, right? Pretty simple, and they seem to be pretty heavy duty. I mean, they're not soft. They do have a pivot to them. See, they have a little ball in there. So if you have an off-angle surface when you're setting this down, then this will comply with that. So I like that. I like the fact that they've actually put some ball joints in these. Right. So what we'll do when we come back is show me putting one of the feet on, just so you guys can get a feel of what's going to happen as far as the rest of the feet going on. So let's put the feet on. And again, we have 3 of them, if you saw the previous segment. And these feet actually already have a couple of, get some focus there, this nut that will come up the shaft and actually be a locking nut. So wherever we put this, we can use this as the locking nut. Now, there's also another nut we're going to put on here, and that is one of these Nylock. And this is an M13 M8 thread Nylock, or locking, anti-vibration nut, safety nut. People call them a lot of different things. But yeah, you can see it's got that blue piece in there that's going to keep it from moving once we have it cinched down on top of here. So we have to run this if you want to start with all of them level, at least I do. And yeah, so I'm just going to run this all the way down here. Now you can just put this on here and get a wrench and start turning it, or if you have a ratchet, you can use that, or if you have one of these, which I do, then yeah, it's simple. I'll show you a quick cut, B-roll here of what I was doing there. And yeah, we just run this bolt, or rather nut, all the way down onto the bottom of the bolt there, and yeah, good to go. And this is actually going to cut your time down a lot if you have a tool like this to be able to do it. Because remember, we have 6 of these we have to do. So then we have, once this is on here, and I have one over here that's already set up. Then we're going to put, you can see it's already got that nylock nut on there. And we're going to put this big thick washer. This is almost a 5mm thick washer, so they're pretty thick. And that's going to sit on top like that, all right? And this is the assembly that's going to be sticking out like this. And you notice we have a little window in here that will allow us to put this square nut on there. Now these are, well, it's actually a rectangular nut. And of course it's an M8 thread also, very thick. It's actually thicker than the washer. This is like 8mm thick, or 7, I think it was 7 something, almost 8. So the reason this is a rectangular shape is that you see this lip down here? This is going to, this piece here is so close to the edge where the hole is that once we put this threaded bolt in there, can't really see it because it's not coming in long enough, but then this is going to be a rectangular piece of metal that's sticking under here. I'm just going to go ahead and put it on and try to let you guys see what I'm doing. I'm just going to kind of pick this back up, take a look at it, look straight down on it so I can see where the threads are, and then I'll put this back on. And while I'm still holding it, I'll just go ahead and run this down like that. So once this rectangular nut that we're using gets cinched up in there, and you don't even have to be tight, it's not going to move anymore, because no matter what direction I turn it in, that rectangular piece is up against this lip here, right? This little lip that's catching that nut. So we don't have to, the whole purpose of this is us being able to adjust this without having to get underneath there and get a wrench in there, right? Which we probably could once this is done, but it's going to be it's going to be very fiddly trying to get in there and get that when all you have to do is this, right? So we can change the height, and then we would run that nut back down to wherever the height is that we want, and then we can take the smaller locking nut and run it up against that nylock nut, and then we're done. Everything's right. But I think I have a pretty level floor, so I'm just going to go ahead and make them all the same height as I put these on. And yeah, so we've got this frame to put 2 more on, then I got another frame I got to put 3 on, and when we come back, we'll see how all that went. All right, so I just want to show you guys the feet and how they are attached now to the base plate, base 1, section 1 of our base of this frame. And you're going to see this come together in our next segment, where I put these 2 center bars on here that are actually going to connect here and here on these pair of holes. And it's going to kind of spread these apart, and that'll be our basic frame. So when we come back, we'll be taking a look at how we're going to assemble that, and then go over and put it all together. And then we're going to have to go to the floor, as it were. And yeah, because then from then on, the build's going to be heavy, and we want everything pretty much located where we want it to be before we start putting too much weight on it. Now we're going to take a closer look at the crossbars, spreaders, or whatever you want to call them, that we're going to be using to connect those 2 bottom frames that we just finished putting feet on. And this also gives me an opportunity to show you a close-up of how these are constructed, because those other things were so heavy. So this is made out of a 2mm steel, just like the bases that we just saw. And we have flanges on here that are actually just over 5mm thick, right? And the flanges have 2 holes. Well, they have more holes than that, but they have 2 holes that we're going to use for mounting. Look at it that way. And there is a proper orientation of how we want this to mount, with the big holes up or down, right? So we'll see that when we go over there. So yeah, and the powder coating is very nice on this. This is a 60mm wide by 60mm wide tube, or if you're over here in North America, that's about 2.4, what was that, like 2.3 inches. That's right, 2.3 inches. And this is a heavy piece. Like all this metal so far, all these pieces, they are pretty substantial. This comes in at 2.5 kilos, and that's 5 pounds and 7 ounces for us over here in North America. And I'm going to show you, give you an idea of the actual welds that we're seeing in here. Very big, beefy welds. I like the look of that. And of course, both sides of the flange are done that way. And they also have a unique way of setting this up, because they actually leave, when they cut these tubes themselves, they actually leave some tabs on them right there, as you can see. So that helps locate this flange when they're actually doing the welding. So yeah, and it adds a little bit of structural integrity, but nowhere near the structural integrity that a good weld will give us, obviously. Right, so we've got 2 of these to put on, and we're going to be using these 30 millimeter M8 bolts. Get over here so you guys can give me some focus here. And of course they're socket head caps, and they are 6 mil. I believe that's 6 mil, yeah. And we're going to be using a big fat 5 millimeter washer on one side, and that's going to go through the flange like this into the bases that are already over there. Then we have another thick 5 mil washer that's going on this side, like so. And then we'll run our Nylock M8 threaded nut, which is actually a 13 millimeter wrench size. We'll put that on this, and we had slots in here on the frames that we just put down there that we're going to be mounting these to. There are access slots in there, so we can actually get in there and get a wrench on it pretty easily. So this is going to be pretty simple. So what we'll do is go ahead and head on over there and get it put together and see what it looks like. Now I have the cross members attached, and yeah, no big deal here, just 2 bolts on either side on those flanges as it passes through the side of these base ones, or the very bottom lower layer of what this cockpit's going to be. And yeah, there's slots in here, so we have pretty decent access here, and I'll go ahead and get down low so you guys can take a look. So no big deal there. You know, there's 13 millimeter nuts and the washers on both sides. Give you a little B-roll here showing me actually using my electric wrench and M6 or 6 millimeter hex wrench, the bent Allen type. And yeah, just get it all tightened down, snugged up. Not the final tightening, because what I'm going to have to do here is pull this off of the blocks according to the instructions. We're going to put this platform flat on my concrete floor here and make sure everything's level. Then I will do a final tighten on these cross members, maintaining the level, hopefully. And once I have that done, then I can put it back up on the blocks, and then we can start putting some covers on this. But we have to have it on the blocks, because remember those access holes, you can see some of them up here, these big holes here for access the other way. But yeah, those holes are underneath here, so we can access these holes on top, the small ones that the M8 bolts are going through, and yeah, be able to get a wrench underneath there, a ratchet, so I can hold it while I tighten everything down when we start putting the cover plates on, and that will be next. Now that we have our base one, or the bottom layer of this cockpit, back on the blocks, we had to level it out. I actually had to adjust the feet a little bit, then tighten everything back up so we got it good and level. Then I put it back up on the blocks, because we're still going to need access underneath to get these plates put on. Right, so there's 2 plates here. Now, these are different plates than the other plates, the cover plates that I'll be putting on, and I'll show you that as we get there. These are pretty thick comparatively to those. The other ones I want to put on are actually going to be 2 millimeter. These are 3 mil thick, and they're substantially heavier than what's over there as far as the other beauty plates, I'm calling them, because they're not going to be load bearing. These are actually going to be load bearing. So even though they're going to be installed on top of the frame, and they're going to have a support here, they're going to have a support over here from the frame rails, and one in the middle, still, this is going to take the brunt of the bearings, and I'll show you those cup bearings once we get there, as they swivel, right? So this one's going to be on the back catching the bearings, and this one's going to be on the front, or vice versa, however we end up with them sitting there. It doesn't really matter, because we can just flip them over and put them in any orientation we want to, as long as we get these little things. Let me show you those. We got some half cut, or not fully cut holes there. See those? And those are index holes that we're going to be using to make sure we line everything up. No big deal, just kind of lay it on there and it happens. It's real easy. And anyway, so these are going to be taking the weight of the actual yaw movement. So when the yaw axis is going to be sliding on here and rolling on this too. And we'll see how all that works, obviously, when we get there. But yeah, we're going to be using some 20 millimeter M8 bolts. The other ones were 30 mils when we were putting those cross members on. These are just little 20 mils. Same thing, M6 socket cap head screw, right? And a stainless unit. And we're not going to be using washers here. The instructions don't call for washers, and there are none, so we won't be using them. But we will be using the nylon lock nuts that we've been using throughout. Again, M8 and a 13 mil wrench. Right, so what we're going to do is go over and set these plates on here. I mean, it's no big deal. We'll fasten them down, and yeah, see how it looks. So I just want to show you guys real quick what I was doing here as far as the process of easiest way I found to do this, because we have these big access holes in the bottom here to be able to present our nuts to the bolt from the inside. And you know, you could just put the nuts on here if you wanted to, but Yeah, I much prefer to have this socket head bolt on here. I think that's going to be the best way for it to present, I think, and show. It's an aesthetic thing, you know? So what I'm going to do is just take this bolt, or not the bolt. I'm going to take this Nylock nut, it's a 13 mil, put it in the socket. Now this is kind of a shallow socket, not a deep. And you can see it presents the threads right there like that. So easiest way I found to do this is just come in like this, put it underneath, and bring it up to the hole where I'm looking straight down on it. And once I do that, I can see where the threads are in that nut, and just go ahead and get the bolt down started. Of course, I won't be able to get it all the way started because of the nylon part of this nut. I have to have a ratchet to be able to make past the resistance it presents. Let's do the same thing over here. And you can see how this just kind of goes pretty easy at this point. And keep moving, just keep moving all the way around, keep doing it over and over again until we get all of them at least attached. And then I'll come back and secure them all and tighten everything down like it should be. And I'll also come back and talk a little bit about that big 12 millimeter bolt that we're going to use in the front, and we'll see that when I get there, for the actual attachment point for the pivot for the yaw element of this platform. All right, I just want to take a minute to talk a little bit about this 12 millimeter bolt that goes through these plates. Now, obviously, I've got all of these 8 mil bolts cinched up nice and tightly. I'll do a little B-roll here just to show you what I was doing with my ratchet, with the extension on the socket reaching in underneath those access holes, and of course using the M6 Allen wrench to just go ahead and run those down tight. And I left this loose because I didn't want it to interfere with me getting the rest of them tight and the holes not lining up right. So I just left this loose. The reason I want to show you this is because in the instructions it just shows you this. Now it shows you the parts of the bolt, but it doesn't show you exactly how it goes together. And it's a little confusing actually from the directions. I think some may not, but yeah, you want to go ahead and make sure you have this nut on the top of this bolt before you put the washer on. Obviously you can't hold the nut up without it, right? Or this bolt rather, without it. And these are 22 millimeter sized nut and bolt here. So you need a 22 millimeter wrench to be able to do this. And then of course we'll just let this, I haven't tightened this down yet and I will in a minute. And we'll just let this sit on top of there. And then of course the pivot frame that's going to sit on top of this is going to come down and rest on this washer. And I'm going to grease this. It doesn't call for it in the instructions. You probably don't need to do it, but I just can't help myself. I got to put a little lubrication on there because remember we have bearing cups that are going to be sliding on this metal surface here. So we probably don't need too much lube, but I just can't help myself. I'm going to put some lube in here. And then of course, once we set this down, the weight of the top platform is really going to keep the pressure on this. So that Nylock nut that goes on top of here, and you'll see that once we get there, it doesn't need to be cinched down real tight. In fact, you don't want to go all the way tight or you wouldn't be able to pivot. So yeah, we're not going to cinch that down all the way tight, but I still like to see a little lube in there just for the heck of it. Anyway, we'll go ahead and get to the next segment. All right, so we have a couple more plates we're going to be putting on the bottom frame, and we're going to be using some of these 20 millimeter M8 bolts again, and of course our Nylock nuts. And not a lot to worry about here, except for one thing. The orientation of these big holes here are opposite of each other once we have this on the frame. And you'll see what that means anyway once we get there. But yeah, same thing I've done so far, so I'm not even going to show me attaching this. I'm just going to show you the result and show you how it should look. All right, it's just a quick look at the result of putting those two plates on. Now, remember, there is an orientation here that you have to pay attention to. You want the big hole on the left side of the front part, and you want 6 bolts in that. And then we come back to the back part here, and you see that we have the big holes on the right side, and we have 5 bolts in. The bolt hole up here is left open because that's going to catch the rear of our traction loss SCN6 actuator. So there we have it. We'll have one more thing to do, I believe, to get this finished, and that's put the plate that goes across these two crossbars here. And that's just going to be 4 bolts, and we'll take a quick look at that. Now it's time for the last plate that we're going to be putting on this base 1, or the very bottom base of this unit. And this is actually a 3.5 millimeter thick aluminum plate. It's not steel like the other ones. So this is aluminum, and sometimes it's hard to tell from the powder coating it's on here, but of course we always have the ultimate litmus test with the magnet that will pick up metal. So Yeah, it's aluminum. So all we have to do is put 4 more of these 20 millimeter M8 bolts through there, but this time we're going to be using the 5 millimeter thick washers on there also, on the top part. So it'll look like that sitting on the top. And we're going to put our nylock nuts on the bottom. So I'm going to go ahead and get that assembled, and yeah, we'll come back and do a quick look at what the results are. So there is the finished base one. So all the bolts are installed, all the plates are installed. We've got that final square piece, which is almost perfectly square, but not quite. And that's, of course, covering those cross members that are attaching the front and rear frame assemblies. So yeah, everything's done now as far as that's concerned. And I think we get to move on to actually putting on an actuator. I believe the yaw control actuator, the one that we left this hole open for, we can start attaching some of that stuff now. So we'll get to that next. Now we're going to be putting this SCN6 actuator on the base 1 platform, so that later on when we put the actual frame part that's going to be doing the yawing, this will be connected to that and cause that yaw to happen. Now, I like that this is an SCN6. I had a Stage 4 Sim-Experience rig for a couple of years actually, and I had a lot of fun with that, but I always felt that the SCN5 actuator they had on the yaw axis was a little bit underpowered for the application. The yaw always felt just a little bit laggy behind what I was seeing and feeling in my direct drive wheel by the time it happened in the back. Of course, that was a very heavy platform, just moving that rear around. Now, it had ball transfers on the rear, which worked well, but they didn't have any ball transfers on the front. It just was these very slick surfaces that it kind of rubbed on. So this is being an SCN6, and we're going to have ball transfers at every corner of our yaw mechanism, our yaw frame assembly. This is going to do a very good job. Now, this is a Dyadic Systems SCN6 040 100BNA. Let's go ahead and flip this around. A BMNA, rather. And I'll show you guys the numbers there. And the 100 is for 100 millimeter stroke. So that's the stroke on this. And I'm going to show you a couple of shots here of the PDF for this motor, and I have it kind of highlighted in white and everything else is yellow. So this is a 100 millimeter stroke. It has a 90-pound max continuous thrust rating on it. And we have 200 milliseconds, or excuse me, 200, not milliseconds, 200 millimeters per second max speed on this. So I think this has got plenty of speed and power to be able to make this yaw action happen, especially since we're riding totally on ball transfers everywhere. So of course we'll have to wait and see, but that looks like it's going to be the case. And it has some, this is a Japanese made servo motor or actuator, servo motors here, but that whole actuator unit. And it's got some good wires that don't look like they're shielded coming out of here. And of course we have our plugs that we'll be plugging into our controller amplifier box, or amplifier box actually. And that's this. And this is the complement unit to the SCN6. I'll give you guys a shot of that. And this is where the amplifier board is residing. And they sell these together. It's got a little LED light over here that should come on when we have everything plugged up. And we have this side going to the actual actuator, and this side is going to our controller, right? So we got a multi-pin piece here for data, and of course we have the power supply pin here, 4 pins for that. So yeah, not much to see here really for that. Now how we're going to be mounting this is first we're going to mount it to this bracket. And again, it's keeping with the theme of a powder-coated black. It looks like powder-coated black paint. Or, not can't be paint if it's powder-coated, but powder coating. But then again, I'm not so sure this is powder coating because I see a chip off of it there. Even though powder coat will chip also. But anyway, it kind of feels like powder coat. But what we're going to do here is set this in here like this. Of course, we're going to pull the label off. And these 4 holes will all align together. And we're going to take these M6 bolts, these socket cap head units, and they are 20 millimeters long, and we're going to use 4 of these to secure this to our actuator. And then we're going to come in and secure the bolt in this hole in the back. Now this bolt is actually what we're going to use to hold it onto our platform over here. And you'll see all that once we come back and see it assembled. So yeah, it's pretty simple here, no rocket science. This is the main M8 bolt we'll be using for attaching the rear here, because that is an M8 hole. And we're using again these 4 almost 5 millimeter thick washer on top and we'll use our Nylock M8 bolt on the bottom, or nut rather. It's not a bolt, it's a nut. Right, so that's about it. Yeah, so what we'll do, oh, one more thing. This is, I want to give you guys the weight on this. This thing comes in at 5 pounds, 7.5 ounces. So a pretty heavy little unit here. And of course, for everybody else in the world, that would be 2.48 kilos. Again, just want to kind of give you as much detail as I can so you guys can, yeah, see in detail what's going on here. So we're going to go ahead and assemble this together, and then I'm going to take it over there and run that bolt through it, and when we come back, we'll actually see what that looks like. Here is the SEN6 actuator attached. We have it attached to the bracket over here, as you can see, our 4 bolts over there, and we'll go around to the M8 that's back here. Oh, and by the way, the bolts that went into the front of this are actually M5, not M6 like I said in the previous segment. So yeah, M5. And we've run the cables through this access hole, and you can see them kind of hanging out down there in the bottom. So yeah, we are ready now to assemble the base 2, as they're calling it, which is going to be the actual yaw platform. And yeah, so we'll get to that next. Now we're ready to assemble the yaw axis frame. And it's really pretty simple, not like going on here. This will go pretty quickly. We have 2 of these cross members here, and they're going to actually act as spreaders between these 2 pieces here that are actually going to be holding our ball transfers, and we'll get to that in a minute. But this, again, very simple stuff. One of these is 752, and the shorter one is actually about 592. So easy enough. We're going to be using 2 M8 30 millimeter long socket head cap screws, and we're going to be using a fat washer on one side, put it through the flange, another fat washer, and then we're going to put our Nylock nuts on. And then it's going to be sitting kind of like this, right? So again, I'm not sure why there's two unequal lengths. They didn't make them the same length, but maybe it's because of the way these holes are offset for something. We're going to be attaching something to that, no doubt. And obviously each end of this bar's flange, once we have it as one piece, these flanges here, this one and one up front there, are going to be attaching to these right in the center. And that just makes sense. Then we'll have one on the front, one on the back. So what I'm going to do is go ahead and assemble these 2, and then we'll come back and look at what we're going to do with our ball transfers for these pieces here and how that's done. Right, so we've got the spreader or cross section bolted together, and again, that was just a couple of M8s on either side. You can see there. And you want to make sure that you can get these flanges lined up as evenly as possible, so there's no twist to them, in other words, because you want this as straight as possible once you have it done and assembled. So we'll just put this puppy over here, and let's talk a little bit about and show you how this is going to work for these ball transfers, or the front crossing pieces that's going to bear all the load as far as the yaw goes. And let's flip this around. Now you see we have 4 big holes in here, and we're going to be putting these ball transfers in the outside big holes. I'm not sure what's going in if there's anything going in these holes. It looks like it's just an access hole for something else we're going to be screwing into later on. So yeah, we'll see all about that once we get there. Now, let me show you these ball transfers. And of course, a ball transfer is nothing more than a ball bearing, a rather large one, that's sitting in a case or a cup, if you will. Pre-done, pre-clamped down. You can see they has a little seam in here where they clamp this down together to make it one piece. And I do like these units because they actually have a lube hole in the bottom. So you can actually lube this while it's sticking in there if you need to. And this is lubed. So if I put my finger across, I don't know whether it's going to show up, but let's see if I get some light on it. You can see how greasy that is. So a pre-lube ball. So that's going to be excellent for us to have these sitting in here like this. And of course, this will be flipped over 180 degrees and riding on the steel plates that are over on our base 1 platform, if you want to call it that, put the bottom piece. And yeah, so this is going to be really great. We're going to have 4. We're going to have 2 in the front and 2 in the back. So very low rolling resistance. Now, where's my rag? We have to take these ball transfers and put some tape on them, because when they fit in there just like this, they're not real tight, but you don't want them super tight either. I mean, you could have it. I mean, I've actually put these into pieces of metal before, and it was so tight as I had to take a a socket and put it around the edge, the metal part here, and actually tap that thing in to get it to go into the hole, which is not great, because then the whole time I was doing that, I was wondering how I would ever get this out if I need to replace it, because it was a closed-in type pipe. And here we have an opening where we can actually push it back out, put a big screwdriver or something in there and kind of just lever it out. But we also don't want it shaking around like that, do we? That'd be making a racket while we're doing our yaw. So, pretty simple solution, and they include this in the kit. This is some electrical tape. It's about 3/4 inch electrical tape, which would be, what would be that millimeters? Less than 25 millimeters. About 20 maybe, I'm thinking. So you take some of the electrical tape, and they say put 2 layers on it. I ended up with 2.5, and of course on this one right here. So you can see it's just wrapping around there. And that'll make it fit better, but also because it's the vinyl electrical tape, you can see I have it up against the lip here where these two pieces are joining, because that's where the hole is going to be sitting. The outside of the hole is going to be sitting on this once we have it in there. So once you put that in there, and this is a little bit snugger, I can kind of wiggle it around a little bit though, and it still goes in pretty easily just by giving it a little prod there, like that. Okay, so easy enough to get back out. It's not stuck in or anything. We have our nice surface there, and now if I try to rattle this, yeah, see, nothing's going on, because it's, number one, it's tighter. Number two, we have that electrical tape interfacing with our edge down here, right? So now it's nice and quiet, and that's what we want. So what I'm going to go ahead and do is finish taping up the rest of these, put all 4 of them back together, put them back together. I'm going to put them in these tubes, and then we're going to come back and bolt the bar we just took away and put over side over there, and we're going to bolt these two guys together using these holes right here. All right, simple enough. Just going to bolt up to the flange that we just saw, and yeah, we can get to these bolts. They got some access holes back here, so we can get our ratchet end in there. So it'll be very simple. So when we come back, I'll have this upside down with all the cups in, or rather all the bearing transfers in, and we should have the spreader done. And then it's a matter of just taking the whole thing over there, setting it down, and clamping down the front part with our bolt and a washer to give us that pivot point for our yaw axis. So when we come back, we'll take a look at how all that went together. All right, so we've got this whole piece assembled now, and you can see I have all of my ball transfers installed. Everybody's tight, but not too tight, and yeah, no rattles anywhere. That's good. Now when you apply, or actually attach, these pieces here to the main cross member, the spreader, you want to make sure you get the flanges as level as possible with the rest of this tube here. And that's just it's just best practices, if you will, to make sure that when you put this on here, there's no twisting. As far as, you want to make sure this thing rides as level as you can on the platform down here once we get it on there. Now we're going to be putting this hole right here onto that M12 bolt, or M14 bolt. M12, it was M12, I think. Anyway, that big bolt that's going to be our pivot. And it's already got a washer sitting on the bolt, so we're just going to slide this down on top of it. Of course, we're going to flip it around. And then once we have that done, then we can get to the access hole underneath here, and we can put our big M12 safety nut on here, or a nylock nut with the extra washer, so that then we have a nice pivot point. So what we'll do when we come back is we'll actually see this sitting like it's supposed to be sitting on the bottom base with this attached, and then we should be able to move it around, see how it does. Now you can see we have this yaw assembly all mounted up to the platform, and yeah, it's working like a champ, nice and smooth. And I really like the fact that we have a ball transfer on each corner here, because it's going to make it very easy to move for our little SCN6 actuator over here. Now I did put the nylock M12 nut on here with the washer, and you don't want to get this too tight, because obviously it won't yaw very well if this is too tight. So what I usually do is run the nut down on the bolt until it stops, and then I'll back it up half a turn, 3/4 turn, whatever I feel is right when I'm moving this, to make it nice and easy to move. But at the same time, we don't want any upward lash on this connection here. So I should not be able to, I'm picking up on it, I should not be able to rattle it, right? So we don't want it that loose. But yeah, right now I can take one finger here and move this. So that's plenty. That should be great. And yeah, on the back part of this, another thing you want to check for, when you put this on is that all of these ball transfers, the ball bearing part, is sitting and making contact with the metal deck. You don't want one sitting off kind of cockeyed. And the one over here was. So what I did was came back here and loosened my M8 bolts. And then once they were loose, then it kind of just fell down, right? So it fell back down and it was all level. Then you just simply tighten it back up. And now the balls are rolling really nicely on the back too. So all balls are making good contact. And you know, it's a great thing when all of your balls are making contact. Right, so yeah, we're done here. Now all we have to do is put our rod end on our SCN6 actuator, and we're going to put a bracket in here. It's going to be an L bracket that attaches to this hole, and then we'll be able to get our rod end on a bolt that goes through that L bracket. And we're going to pull this out to come get that, I think. It's pretty tough right here, but I think I can get it to come out far enough to make the attachment. So then that'll be our attachment point so that thing can push it back and forth like that. So when we come back, we'll be installing the rod end on this and also the bracket that goes on the side there. Here are the parts we're going to be using to actually attach our actuator to the frame that's moving on the Z or yaw axis. This bracket is what we're going to use to actually make the attachment or connection, and we have a long slot in it here so we can adjust it front and backwards just to ease the installation of our rod end over the bolt that's going in here. Now this has a hole here that's actually an M14 hole, and we have this huge M14 bolt that's going in there, right? You got a hex head on it, and it's just going to sit in here like this. Now you have to put the bolt in first, because this M8 bolt that we're going to be used to actually attach it to the frame, and this is an M8 30 millimeter M8 socket head cap. Once it goes in there, we're not going to have enough clearance to get this bolt. You see it come back out here. If I can push it out, it's going to hit that socket head cap part. So we have to have this in first. And then we're going to put on the rod end that we've already attached to the front of the actuator rod that comes out of the actuator. And that is, we'll give you a shot of that, the rod end. A very nice rod end here, high quality stuff. All this stuff is high quality so far that I've seen. And yeah, so that's M14. That's what that 14 stands for on there. So it's 14 millimeter on the hole. So this will slide in there just barely. Okay, it has a little bit of lash, just enough to let us get it in there. And that's what you want with a rod end. And then we'll come back with this M14 nylock nut and put it on top of here. Now there are no washers here on this side or this side. And the reason is we have to engage with some threads this nylon part of this nylock type safety nut, right? So if I put the edge of that safety nut right on the edge, there goes my MA bolt. That's all right, we don't need it. You can see that it's, yeah, going down just enough to get good engagement on this part of the threads, the top part of the threads on this bolt. All right, so if we put a washer in there, it would kick it up a little bit too high, and we might not get enough engagement of these threads into that nylon part. So that's why we're doing it that way. So we'll just spin that down, and of course we'll tighten it down once we get it to where we need it to be, and then our rod end will be able to be free as far as moving around. You can see how it can, well, let's do it this way. See how it can move around there? So it doesn't bind up, no matter what kind of angle it might get at. Now, the rod end itself, I'm going to go over and install that there, and we'll do some close-ups of that. And the only trick to this is the actuator rod that comes out has a notch on it. Now this is, I believe, a 22 millimeter size here. You see how the sides are flat? Right, so we got a notch on each side. That's how we hold that. And we have another 24 millimeter nut on that actuator shaft that's going to run up against this and lock it down. Once we get it to a point as far down as we can without having it sitting like this, we need it to sit it perpendicular like that. So once that is, then I can run that other nut up, and you'll see this in the close-up in a minute, and tighten this up. But when I'm tightening this up, I have to be very careful that I do not twist the rod that's in the actuator itself. It's a big no-no with these actuators, these SCNs. So you don't want to twist it. So I'll have a wrench there to hold that while I'm tightening this, just to make sure that that does not get twisted at all, right? Now, I can't take the rod in this actuator, won't come all the way out, and I'll discuss that again once I get over there. It's sometimes these new actuators, when they come from the factory, you can't just pull that actuator shaft out. You have to energize it first. In other words, we have to power it up, have it connected to the system before it will move. Now, once it's out, you can usually move them back and forth a little bit. It doesn't matter then. But I believe there's some kind of a brake our locking mechanism when they ship these things, so that there's no way it can come out, because I've been pulling on it, it won't come out. So anyway, we'll get to that once we have the system all connected, and that's not going to be a problem bolting all this in for our final installation, because we have plenty of access to this part of the frame, even when we have everything sitting on top of it. Right, so enough of that. You know what we're going to do. So now let's go over to the yaw axis frame, and I'm going to at least install the rod end, and I may just temporarily install this in there, because I think I'll be able to get the rod end on here even with it sitting in there. If not, it's not a big deal either way. Now I'm going to install the rod end onto the end of our actuator's rod or shaft, whatever you want to call it. And you can see we have some threads here, and we have this lock nut. I'm going to run the lock nut all the way back, because I want to engage as much thread as I can into our rod end here. So let's go ahead and do that. Real easy stuff here. There's just, you have to be very careful when you do the tightening, is the only thing really to pay attention to. And I'm going to go ahead, and you can see I turned it all the way in. It's up against the lock nut, but obviously I don't want this angle. I want it straight up and down like this. There we go. So then I can take the lock nut and put it up against the rod end like this, right? And now I'm straight up and down. This is where I want to be. So when this goes in, it'll be, the bracket will actually be sitting on the side like this, because we have a hole here for our M8 bolt, and this is going to be going through the rod end like that. Real simple. Nothing, it's not really difficult to understand that. But I can't install this yet because I need the rod to come out, and it won't come out until I activate it or hook it up, as I discussed before. So we're just gonna have to wait till we get to that portion of our review, the build review, and once it comes out, then I'll be able to install this no problem. Right, so let's go ahead and tighten this up. And this is the kind of tricky part. You just have to be patient and take your time and be careful. We don't want to put any kind of twisting on this rod or shaft that's in the actuator. That's a very bad thing for these SEN type of actuators. So we don't want to do that. I have a 24 millimeter lock nut, and I have a 22 millimeter slot on each side of this rod end, so I can actually do that tightening. So I'll go ahead. What I typically try to do is get this to where I can just kind of squeeze it together to make it work. What I mean by that is position my wrenches. So yeah, well, let's see. Let's do it this way. I'll put this 22 on first this way, and now you can see I have kind of a scissors thing going on here. So I'm going to look down straight on top of this rod, make sure I'm perpendicular, and then I'm going to kind of squeeze them both at the same time to tighten them up without putting any stress or twisting motion on the actuator. So I'll start softly so I don't move anything more than I need to, and then I'll start to torque down on it. Now you don't have to torque the heck out of this, right? This should hold pretty well just by putting some good tightening effort on it. Again, making sure that I'm not stressing or twisting that rod that's in the actuator. So I'll just kind of do that. I think it's tight as she's going to get. And the rod end is not perfectly perpendicular, but it's plenty, because this is a rod end, remember, and it's got that ball in there that can compensate for just being off just a little bit. And I don't want to do this too much, because I don't want to have to keep going back and forth and take a chance on twisting that. So now that that's done, I'm not going to be able to install my bracket yet. And here's the M8 bolt. It's going to go through the hole we have here. It's a little hole here. And obviously I'll go in behind it with our washer and our nut and secure it. After I have this connected, go ahead and pull this out. So I'm going to run this in first. The M14 bolt, I'll put that through the rod end first like that, and then I'll secure it. Because remember, we can't get this in because the head of this bolt's going to be blocking it from coming in and out. So yeah, it doesn't work that way. And I possibly could get in here and connect this like this, right? But then I've got this whole part of the frame that has the bearings in it off at an angle, and I want it straight when I put the rest of this stuff on. So I'm not going to do that. I'm just going to do this and let it kind of hang there, and I'll make sure I don't lose this. I'll set this bolt aside as a special bolt for our axis actuator, or rather our yaw axis actuator. Now we have one more thing we have to do to our yaw axis frame, before we start building the frame that's going to actually to be holding these guys, right? And yeah, so these feet on these actuators need a place to land, and that's what these are. These are, I believe these are M14s. Let's see. Yeah. So that's an M14 thread that we have sticking out of the bottom of this cup, or whatever you want to call it, sleeve. And the sleeve is actually, let's see how wide this thing is. I believe it's like 60. Yeah. So it's 60 mil on that, on the sleeve. And I believe it's about 60 mil thick, or deep also. So let me move around here so you guys can see this. There we go. And that's 62 mil deep. And the powder coating is the same as the rest of the frame, so it's kind of keeping with the theme with everything else. And yeah, this is what I would call a non-captive type of foot, because once this goes on here, let's turn this around so you guys can see me doing this. All right, so once it goes on here, it still has some move to scoot. All right, so this will keep it from binding up in this cup. But yeah, I don't know how much movement you're going to get because of that, but obviously the guys at Prosumu know what they're doing as far as how much they can have to move around. Not only that, but it helps us line this up. Once we have it on the frame that's going to be sitting on top of the yaw frame, it helps us line this thing up so everything is nice and straight and level. And of course we have some things we're going to be leveling with this actuator, but we'll get to these guys later on. We'll talk a lot in detail about those. Right, so it's a matter of putting this on the frame in one of those holes that are in. Remember we put those bearings, the bearing cups, they have other big holes next to them on the other side, and that's what we'll do. We'll set it in the big hole, we'll put a washer on it underneath, inside the tube, and then we'll run our M14 nylock nut in there. And we're not going to tighten these all the way down yet, because we still want to be able to move them around. I'll probably say that again when I'm over there actually putting these on. So yeah, pretty simple thing to do. So let's go on over there and get it done. Now I can install my foot cups, and very simple thing that's happening here. We're just going to set this on top of the big hole here, and because this is such a large flange and a large surface area, we really don't need a washer right here, but we are going to put a washer underneath it, right? Like right here. I'm going to kind of hold that there. Go ahead and get our M14 nut, and I'll just kind of slide this around until I get it started. Well, get it started. There it goes. And of course, once it hits the nylon part of this nylock nut, it's going to be a lot harder to turn. Now, I don't want to get it all the way tight, but I do want to get it snugged up because I still want to be able to move it around a little bit. So when I drop the actuator foot in here, I can make sure I can get each side of this thing leveled out the way I want to, as far as this way, frontwards, backwards. In other words, we want it nice and squared out if we can get it that way. Only problem is, now I can put my wrench under here and just kind of turn this, but it's getting really hard to turn, and the edges up here, they're not sharp, but they're not comfortable either. I could get a big glove or something, but what I'm going to do is take one of these oil filter wrenches, these little rubber jobs with a rubber strap, put that on there. Then I can get my wrench back out here, and yeah, then just start turning it. Now I have a lot more leverage on that cup to be able to turn it in the direction I need to. Now I can also get a socket under here, but the whole deal with this is you can't really get, a lot of swing on a socket in there anyway, so you might as well be doing it this way. It's actually going to be a little easier in the end. And even though it's not the best way to do this, I'm sure there's probably an easier way somewhere, but I'm just using the tools at hand. And yeah, so just spin this around until I get it. I don't want to get it tight, but usually what I end up doing is getting it just a hair too tight, and then I'll have to loosen it back up. So there, it's still moving, so I'm just going to keep tightening this thing around here like this until, I can feel it snug up a little bit. And then right there. So now it's not moving at all, which means I'm still going to have to get it. See, it's just barely moving there. Yeah. So I'm going to flip this around and go the other direction to hold it. And yeah, we'll just spin it a little bit in the other direction just to get it loose. And then we'll see what we get here after doing that. There we go. So now we pull this back off and take a look at what we've got. And this is a great wrench, by the way. if you are a Fanatec owner, this is a great way to tighten up that nut on the podium wheels. You can get it tighter than you could with anything else. It really does a great job. Yeah, so yeah, you might want to try one of these on that nut and really get your connection nice and tight. Right. So here we are. It's nice and loose now. I have plenty of room to adjust this back and forth around to where that cup needs to be so the foot comes in there. Then once it's all set down, I can tighten it all back down and yeah, be done with it after that. So what we'll do now is get to the next segment. Let's go ahead and get the final major frame part called base 3 in the instructions assembled. Now, what this is going to consist of are 2 spreader bars that are going to be attached together. And they give you 2, and when you attach them together butt to butt, like this, on these flanges, yeah, there you go. It's going to be a long spreader right there. And as typical of the construction so far we've seen, again, we have the flanges with the little locating tabs before they put the welds on them. And again, very good looking welds all the way around here, and the powder coating looks good. Now there is an orientation for these. We want these holes to be on the same side. So you can see this one has the holes here. So we want to connect them so the holes are on the same side, because we have other holes on this side that we're going to need for attaching the cockpit on top. At least I believe that's how it's going to go. So we had to put these together. Now these are actually, I mic these out, these are 3mm thick metal, not thick, but thick metal. And the other tubes were like 2mm, but these are 3mm. So that is a different change, and the weight is different too. So this is definitely going to be one of the heavier, dutier parts of this frame assembly. And rightfully so, because these cross members, once we've attached them together, they're going to look like this. I'll show you one I already have built. And we have 4 bolts on each side connecting those flanges. We have our holes lined up like we should. And then we can see the holes on the other side. So this is going to be attaching the 2 bars that are going to be holding the actual actuators. And they need to be strong, obviously. And all this stuff needs to be strong at this point. So what we'll do next is go ahead and get this one assembled. And I'm going to come back and show you the other major bars that are actually going to be holding our actuators, and how we're going to connect these guys, these long pieces, to them. And they'll be on each end of the front and the rear of our chassis or cockpit once it's all finished. Now that I have the spreaders or crossbars assembled, and I have them laying over there, and we'll see them once we take these over there, sitting on some wood blocks to get them up a little higher so we have some clearance. These are going to be the front and rear crossing bars that are holding the actuators. And you can see on the bottom here, there's the 4 holes for the flange, and of course the pass-through hole for the actuator foot itself. We'll spin that around, and that's where they're going to be sitting inside of here. Now this is a pretty massive tube. It's like the ones we just put together that are part of this whole base 3 assembly. This is actually 80mm by 80mm. Again, this is larger than what we've used so far. And again, this is a 3mm, a little over 3mm thick steel. So yeah, heavier, dutier, but obviously there's a reason for that, because this is where the actuators are going to land, and these are going to be taking a lot of the stress. So that's why they're built like that. Now, what I'm going to have to do here is, really there's nothing to show you else here, because what I'm going to be doing is, you see these, we have a set of holes on either side of here. We have 4 here and 4 here. And of course, they're going to receive the flanges of the crossing bars that I have sitting over there on the platform now. So what we're going to do is take these over to the platform and set them on the cups. And that should align me just about right where I need to be to affix these bolts and get everything stuck together, so we have the 2 crossing members and these guys sitting on the front and back. So we'll go over to the platform and see how that's lining up. So base 3, or the actuator base I'm calling it, well, maybe call it the actuator cockpit base. Anyway, the last base to be assembled is now assembled, and you can see we took those 2 crossbars that we assembled before and attached them to the bars that are going to be capturing the actuators. And you can see I have it up on blocks, because next step is to start mounting our actuators. And you're going to need room. Once we put the actuator in this flange, right, and we bolt it down, there's going to be some actuator feet sticking out the bottom, quite a ways actually. So I'm actually going to have to, let me give you a shot of it here. You can see it's just even with the cups right now. So I'm going to have to go up another 6 inches or so that the actuators, when they're hanging down, actually clear and are above these cups. And it says in the instructions to put some cardboard boxes under there or something like that. But yeah, I don't have any cardboard boxes. I think they're going to hold this. This is a very heavy piece here, this frame. Yeah, you need a buddy to help you put this together and set this on top. I think it's advisable anyway. But yeah, everything's bolted together. I mean, look at all these bolts. Reminds me of the old rivets in iron buildings of days gone by, the way they constructed them. But this should be pretty stiff, I would imagine, considering the weight and the way it's assembled. So yeah, what we'll do next is get this thing elevated even more than it is now, and then we'll start putting in the actuators. Now we'll take a look at the actuators we'll be using on this kit. This is the ProSim-U PRS 200 actuator. Now they come in 3 lengths or available travel distances. They're in 100, 150, and 200, a whopping 200 millimeters of travel available. These are actually the 150 millimeter or 5.9 inches, which is basically 6 inches when you're sitting in a cockpit going up and down. I don't think you'll be able to tell a difference between a tenth of an inch, but you might. So that is a lot of movement. And actually, I'm looking forward to getting in this rig. I haven't been in a rig with a full 6 inches of travel yet. So again, I'm looking forward to seeing how that does. Now, they're very fast actuators. According to ProSim-U, they can move at a speed of 280 millimeters per second. And of course, this is only 150 millimeters, so that just shows you how fast this thing's going to be able to react. Now, it can provide up to 2 Gs of acceleration, which I imagine would be pretty nice on the heave, which is actually on the Z-axis. The heave going up and down, yeah, that's pretty quick. Now, maybe it's too quick, so I hope there's a way to calm this thing down if it's, it feels too jerky or quick and snappy, because it's very fast. And that's up to, well, no, not up to, but 200 kilograms per actuator capacity to support. So that's 800 kilograms on all 4 of these once we have them mounted. And up to 193 kilograms, this actuator will continue to deliver the 280 millimeters per second 2G acceleration numbers, up to 193 kilograms. Now, I like that ProSim-U actually states the performance of their actuators under load, because there's a lot of actuator information out there that never does that. They just tell you that, it does whatever millimeters per second and how much G-force of acceleration it can do, but it never tells you if that was tested on a bench laying sideways like this with nothing on the end of it, or if it was under the full capacity or almost full capacity load. But even this actuator, ProSim-U, admits up to 193 kilograms, it will do those numbers or deliver those numbers. But once you get to over 193 kilograms, then it starts to degrade in performance, which makes sense. It has to degrade somewhere. So yeah, that's what they're saying, which is not really, that's not that much less than the 200 kilograms. So this is the numbers anyway indicate that this is going to be a very high performance actuator. And again, I can't wait to get it on there to find out. Now this is a very heavy actuator. It is it's 19 pounds, 5.5 ounces. But for everybody else in the world, that would be 8.77 kilos on this. So yeah, it's a hefty piece. And yeah, we'll get a little closer look at what's going on here. This is, again, it's the PRS 200, but it's got some other numbers on here. And something in here must indicate the length of the travel of this. But we can see this was actually made in 2019, not too long ago. Right? And we've got a little caution tag on the back here. And we have our 2 wires coming out. We have over here the encoders usually on the back of these motors, so that makes sense that we have this wire coming out that has all the plugs in it for the data connections. And this wire underneath, where the motor actually is going to be our power connector, right? So 4 leads for power there and signaling. We have a breather hole with a brass, it looks like a brass screen in there to keep the dust out. And we have this long, what I'm thinking is aluminum tube. We'll find that out in a minute. And we got a huge flange on the bottom of this. It's over 12 millimeters thick. So a very large flange, which obviously is supporting the kind of torque that this thing's going to be able to put out is, yeah, a good thing to have, no doubt. And if you look at the bottom here of the actuator rod, you can see it has those notches on it, so that we can actually put a wrench on here and hold it still, because we're going to be doing some adjustments here with the height of this foot. And you want to be able to hold this with a wrench when we tighten this down, because we don't want to put any kind of twisting motion on this actuator. That's bad news for these actuators. You don't want to do that. So speaking of that, while I have it up here, if I can hold it up here long enough. I know I'm not that weak, right? All right, so against my black background here on my shirt, I'm actually taking this out. We have a lock nut here, and I'll spin that down. And I've actually moved this sleeve. You can see it's got a bunch of threads here hanging out, right? So I put the sleeve down a bit, but not all the way, because we're going to have to level this out, or at least have the capability to level it out. So I'm going to leave, you know, a bit of room there, right, for the nut to be able to move up and down a little bit. So if I'm way out of level, I'll have enough, still have enough room to get these leveled up. But I don't think I'm going to be that far out based on what I have so far. So that's another thing we do when we're installing it, and I'll show you that once we're putting it on. Let's see. Rubber foot on the bottom here, and you can see I can actually push that down. So it will be a nice soft landing, it should be anyway, and provide dampening on the motion or the action and torque that this is going to be putting on the frame. So yeah, not much else to see here. It's, again, a very impressive actuator in hand. And I'm going to just test this real quick. Yeah, these are aluminum in here. All this is aluminum. Even that is aluminum, the flange there. Of course, this is all steel. Except for this, the cap's aluminum. All right, and our flange is steel, yeah. Which makes sense, because this is going to take the brunt of all of the forces of this actuator. Right, so we're going to take it over and install it. And we're going to install it with some 30 millimeter, get these out here for you. These 30 millimeter socket head caps that we've been using all along throughout these stainless steel units. We're going to put a thick washer underneath on the bottom of the frame that we're going to be bolting it to, and we're going to use our Nylock M8 nut here. So simple enough. We're just going to put this through like this, and then we'll put our washer. You guys can see that. Let me put it over here so you can see what I'm doing. And we'll put our washer. It'll sit down inside the frame, and then the bottom of the frame metal will be here, and then I'll put a washer and a nut on that, and then we'll torque everything down and make it nice and tight. So what we'll do next, and again, once we have this attached, I'm going to have to lower the top frame back down into the cups, and we'll be adjusting the cups too. If you've been following along, you know what I'm talking about. And yeah, so let's go ahead and just get these things installed and see what they look like. Now we have all of the actuators mounted to the chassis, and yeah, it was a pretty simple matter of just lining up the flanges, and get a little top-down view here. You can see there's our M8 bolts on either side, and we'll go down here and take a look. You can see inside that big 12 millimeter thick flange sitting in there, and underneath we have our thick washers and our nuts. Now I already have it sitting in the cup, but it's not under full load. As you can see, I've got some 6x6 wooden blocks here sitting underneath the front and the rear over there, with some shims just to get it just high enough so these feet aren't really making contact with the cups. The cups are still loose. You can see I can still move them around. And we're supposed to get this leg or cylinder right dead center of the cup. So I'm going to be moving this cup around to get it to line up so when this comes down, it's dead center. Now I can still move this whole chassis back and forth, right? So I can move it back and forth this way to get it lined up. I want to get it lined up evenly with this bottom piece down here, so I don't have this cup sitting way out here on the edge. See how it's sitting outside there? I want it more centered back towards the top of this. Right, so that's kind of just a fiddly thing you have to do. Just go back and forth on the front and back and just get it so this whole top frame is lined up as straight as possible over top of the bottom yaw frame that's holding the cups, obviously. So yeah, that's all we have to do is get that done, and hopefully this is going to be level when I set it down. But I did adjust every one of the feet on the bottom of these actuators to the exact same size as far as length goes. So I've got a feeling it's going to be pretty level right off. But if not, I can always jack it up a little bit and get in there and change the height by, as you saw before in the other segment, by changing that big metal sleeve there, and then locking it back down with a lock nut. Right, so that's what we'll do next. So our cups are secured now, and you can see that the actuators and the top frame are now sitting totally on the cups. All the wood blocks are out, which is what we wanted. And yeah, you can see the bottom nut down there is nice and tight. We'll come back up and take a look and see what that looks like as far as the whole thing setting. And now I have to say, this is a very nice, these transfer bearings, I mean, I'm just taking my hand and one finger pushing this back and forth. It's just so easy to push. That SCN6 actuator down here is going to have a rather easy go of it, even when I'm sitting in it and have the rest of the cockpit on top. Very smooth, very slick. And you know, it's always a concern when you're bolting all these parts together, and we have these beams that we're bolting together and then bolting beams over to other beams, how level this is going to be. Because usually you have to tweak things around to make sure everything gets level. But as I built this, I checked on each level of building each one of these frames, the base 1, 2, and 3, that it was as level as I could get it before I set it up. And that really turned out pretty well for us, because you can see there's my level right there for the front to back longitudinal axis. And we'll take a look at what we have over here on the lateral axis, and you can see right on. Beautiful. Yeah. Of course, it did take some time to get all this set up like this, and of course it takes a lot more time when I have to stop and shoot video all the time for you guys, but hey, that's what I do, right? All right, so this bottom section is all done now. Now I'm going to go ahead and put the cockpit on top, get the seat mounted and pedal trays and things like that. All right, so now what we're going to do is put our, what I'm calling the floorboards on this, on the chassis over there that's actually holding the actuators that we bolted the actuators to. Now this floorboard is so when you step into your cockpit, you'll have something to step on and things won't drop down into the motion parts of it underneath, which is always a good idea, I think. And we're going to be using, to do this, some M8 bolts, the usual ones that we've been using throughout this build. And this is a 20 millimeter socket head cap, and we're going to be using a thinner washer this time, not the big thick ones, and a nylock nut we'll be using like we've been using throughout. So right, the only consideration is there is an orientation for this, the hole patterns on these. Not a big deal though, it's easy enough when you set it over there how to figure it out. But we also are going to be putting the rails for the cockpit piece of this chassis. All right, and this is what it looks like. So this is going to sit on top of our floorboard, and you can see we have some slots in here, right? And there's actually holes on the other side here that we can actually put a bolt in, and we're going to use those rectangular nuts in here to secure this to these floorboards where these holes are here. So where we're going to be putting bolts here, we're not going to be putting bolts in the floorboards. The whole point of this conversation. So yeah, that's what we're going to do. So I'm going to do is go ahead and get the floorboards installed, and then I'll set this on top of it, or just kind of lay them out, and then I'll set this on top of it and see which holes are going to be exposed on the floorboards themselves. Probably the ones at the back, I would imagine, in front, and those are where we're going to put bolts straight down into. And then of course the other stuff, the other ones, we're going to be putting the T-nuts in here, or those rectangular nuts, and then securing it from the access holes. I'll show them right here. See, we've got some access holes here on the bottom, right? Easy enough, not hard stuff. And this again is just the rails of the cockpit. We'll be putting the pedal plate up on this location, in this area where these slots are, and we'll put our seat back here where the seat rails are going to go to capture our bucket seat. The plates are sitting on the beams now, and all the holes are lined up properly, and it's just a matter of figuring out which plate goes where. There's only two of them. It's easy to figure out. We're going to be putting the rig on, or the cockpit rails on like this, and it goes all the way up to the front edge here, and we have a hole up here that lines up that we'll be mounting, and we have a hole back here that also lines up, and we're going to have two bolts mounting the front and the back, and then we're going to have two more bolts back here, and that's going to keep all of our plates in place so they don't slide around. And yeah, so what we're going to do next is just go ahead and get this bolted down, all of it, and see what it looks like when we come back. Let's talk about the wheelbase mount. First off, we'll go with the big piece here, the complex assembly. And we have a couple of tubes here that are welded together with some nice welds here that are ground down. And yeah, it feels very substantial in hand. We have the bottom tube out here that I'll show you how this attaches as I do it. And this is just going to, once we have this thing assembled, it's pretty cool that we can actually just slide this into the tube that's attached to the side of our frame over there and then tighten it down. The flange here, this is going to obviously hold our wheel deck, which is this guy right here. All right, and we'll take a closer look at that in a second. And it has these slots cut in it so that we can obviously change the angle of our wheel deck to whatever the requirements may be. Again, very nice welds everywhere you look here. Got one there. And this is just another support that's going to be running on the frame also. And yeah, big welds there. Big welds in the bottom under here. And the flange itself has some nice welds on the top and bottom. And the flange is, let's go ahead and mic this out so you guys can get an idea of what this is, how this is made. And there we go. What is that? 3.7538. Okay, we'll call that 4 mil. All right, so that's a decent sized plate, I think. 4 mil is definitely better than 3 mil. And yeah, so not much else to see on this piece anymore as far as what we've covered so far. Let's take a look at the wheel deck that's actually going to bolt onto here. Now this is a massive piece. It's very substantial when you pick it up. It has the usual pattern for the usual suspects for mounting. I believe these three here would be for the Fanatic. And then of course we have the Logitech Thrustmaster and, like I said, the usual suspects. Now we have a slot here that will be attaching to that flange we just saw. The welds here are very nice, very big and beefy around the side there. Even got one down here in the crease, but it's a little smaller. Can't really see it that well. And we'll mic this out. This is also a very big sheet of metal, very heavy. Yeah, this should do a good job, I'm thinking, with a direct drive wheel. So that's over, yeah, that's 5.3 mil. There we go. Yeah, so that's almost 5.5 mil thick. And it feels heavy as soon as you pick it up. Yeah, there's no hurt in this piece of steel. Right, so the last piece that we're going to have is this one. And this is a crossing member support piece. This piece will go up against the wheelbase frame itself. These two holes here, see those two holes in the bottom right here? This is going to mount on that, just like this. All right, and then it will cross the cockpit rails to the other rail opposite of it, and this flange right here will bolt to that. So we have, it's nice we have this crossing flange, or this crossing piece rather, to help support the wheel, and it's not just going to be some bolts on this, on these sliding rails here and another one over here. So yeah, this is this is definitely going to help the stiffness of the wheelbase itself. Of course, you know, we don't know for sure what's going to happen here until we actually have it mounted. Good welds here also. This is all one piece. This metal piece here, it curves around, then goes down in here like this. And I believe this, yeah, this is all one piece. And they stamp this curvature here that's going to go across. And of course, having it bent like that gives it a little more structural integrity. So yeah, no complaints here. Good welds everywhere as usual. The powder coating's nice. Now let's look at the shifter mount that we'll be using, and we'll go ahead and mic that out right here. And that is about 3.1. We'll just call it 3 mil. That's probably what they intended this to be. And we have some slots here for mounting different shifters, probably the Thrustmaster, I'm thinking. And I'm not sure what these slots are for, but I'm probably going to run a Thrustmaster shifter on this. Haven't decided yet. And again, we have some nice welds in here on either side. And yeah, we got some down here where these pieces are attached. See if I can get the light on those welds. There's one there. And there's another one. All right. So again, very stiff feeling piece. And of course, all these holes are going to give us the option of where we mount this within limits. And you can see that I have 4 holes towards the top here where the wheelbase is going. And this will be able to fit up against that with 2 of these holes. Now we can raise it. Actually, there's 2 positions here we can put it in, here or here. Well, actually 3. So we have 3 positions this way. And of course, this way, we have a lot of positions. So again, this looks to be, the way it's so short and the way it's going to be attached to here, I would imagine this is going to be a pretty solid shifting mount. But we'll have to wait to see, obviously, until we have everything bolted up and running. So what we'll do next is pre-assemble this, and I'll show you how I do that, some of the trickier parts if there are any, and then we'll go over to the pedal tray and see how that's working. All right, so let's get this puppy assembled. The most difficult part of this is going to be setting these rectangular nuts into this hole, or a nut. The rest of them are pretty reachable. And if you do this one in the right sequence, not too bad either. Now, it's easy for me to put my finger in here, in this hollow part, and take this nut and hold it in with my finger, and then put the bolt in. No sweat. Unfortunately, this hole back here, well, my finger's just not that long. So, what I'm going to do is, firstly, we're going to have to go ahead and put this up here, right? So you guys aren't going to see this too well in what I'm doing here, but I'll try to swing it away once I get this hard one in. And so I'm going to set this up here, and hopefully it won't fall off. There we go, because there's a lot of weight over here, so it wants to tilt a little bit, but so far so good. And now I'll just take this and take my little plastic, I don't know what you call this, a pry tool, the general overall all-arounder kind of tool that I use for all kinds of prying and getting into things, because it's a non-marring plastic. It's actually from Old Dominion Glass. I used to do windshields and stuff on cars, and yeah, we used these a lot. But anyway, so the idea here is to put this on here like this and kind of just lower it down, and I'm going to shove it all the way in here, I hope. And then before I lift it, I'm going to just kind of slide it in there and look down until I can see it. And there it is. And then I'm going to lift it up. And I have my nut ready. I run my bolt ready. And I can see it in there. So I'm going to see if I can gently get the thread started. And it looks like... Let's see. Was it successful? Yes. All right. So that worked. So again, that's just the technique I use. There's probably something else that we can put in here and make that happen. And you can see now we have it attached. And I can go ahead and just get this a little tight. I don't want it too tight because I'm going to swivel this around here and do the same thing with the other nut. But fortunately, it's close enough. All I have to do is hold it up there. And again, I'm going to look straight down here in this hole and see if we can get it started without any drama. And it looks like we're good to go there. Yes. So these are cool nuts because they're not going to twist once we tighten things down. They're going to lock up against the walls of this tube here, which is kind of nice. I like the way that works. But yeah, it's a little bit easier than if I had to hold a nut all the way in there. A regular hex type nut, it probably would have swiveled around on me. So I'm going to leave this kind of loose. Don't want to get it real tight because we're going to take this whole assembly once we're done, and we're going to be sticking it over there onto the cockpit rails. Now, let's go ahead and get this piece done. Now, this is the steering wheel assembly, and we have this big slot in it right here that's going to have to be lined up here. So it's going to have to sit like this. All right. In fact, let me turn this around a little more. You guys get a better picture of it. Like this. All right. So we're going to put another 2 of these rectangular nuts inside of this tube, right? So we have to slide them in here and then proceed onward. So first off, if we put this one in, I'm going to put this one in first, the one that is closest to the front. And then once I have that secured, because this is a slot in here, right? I can just slide this down and then put the other one in. Well, I can still reach it easily. If I did it the other way, I wouldn't be able to reach in here and get the other one for this slot. All right, so again, it's just a sequence issue at this point when we're talking about this. And I'm going to go ahead and lay this in here. A better way I can show you guys what I'm doing here. Let's see, we're going to do it this way because our wheelbase is going to go that way. Okay, so I'm going to go ahead and lay this one in here and go ahead and take my 20 millimeter M8 nut with a washer again and see if I can't get it started. Again, you got to kind of wiggle things around here. I'm kind of off angle because I'm trying to show you guys what I'm doing. If I can get it through there. Okay, there we go. All I have to do is, I can see in there that the nut's locking up against there, so it should be good to go. All right, so leaving it loose, now I'm going to slide it further over and now put the other nut in the same tube, right? And I should be able to do the same thing I did over there. Now that last slot was a little tight on the bolt itself, so again, that's just one of those things you have to wiggle around to get going properly. I can get this one lined up. Again, the way I'm off angle here looking at it is not conducive to doing it quickly. But you guys get the idea what I'm doing here. All right, give me this washer, put it over here. Or this nut, rather. There we go. Maybe that'll work a little better. Again, it's a little tight in these grooves, or these slots that are cut into here. So that's also giving me a little bit of drama as far as making it easy to start. You know what I'm going to do? I'm just going to hold it. Maybe that'll help get it started in here. Oh, the other one went in so easy, and that one was the first one. Man, I can't get this bolt. There it goes. It's really tight in this slot. That's the problem. Okay, there we go. So now we got it in, right? So there we have it. Okay, so we got the bolt in there, and we can go ahead and kind of snug this down a little bit. Obviously, I'm probably going to want my angle to be flat. And yeah, so we don't want it swinging around, so I'll just snug that up a bit. So, only thing we have to do now is, and I'm not going to do that yet, I'm going to wait till it's on the cockpit, is install my shifter bracket here, right, that I just showed you before. So as a unit, let me go ahead and bring this back a little bit. You guys can see this. So as a unit, we're ready to go, right? And so the idea is to just slide this thing in. I thought that might shift a little right here. And you'll see the extra tube that's on the side of that rail over there if you didn't see it before. And we're going to put a couple of the same nuts in that, and then we'll just be able to slide this in. And once we slide it in, we can adjust it where we want it. And we also have another mount point here to help with the structural integrity of this thing moving back and forth, right? And again, not sure how well this is going to work, but it feels pretty heavy in hand. So I'm thinking that this is going to work pretty well. Now what we'll do is go ahead and get onto the pedal tray assembly and see how that works. The pedal tray for the Prosim UT1000 looks like this. And this is the bottom part of the tray that actually mounts to the cockpit rail assembly. And it's a pretty heavy plate. We can see we have some adjustments here for angle and also for where you want it to be as far as frontwards and backwards. Unfortunately, there is no height adjustment here. I would have liked to see something like that up here where we could actually adjust the height, but yeah, not on this one. We've got the Prosim U water jet logo in there, pretty cool. This plate looks to be about the 3 mil, I'm guessing, because I've been messing around with these plates so long now in this construction. So yeah, let me see real quick. It's kind of heavy, so I'll just do, yeah, 3.1. So that's a 3 mil plate here. And over here, we have a heavier feeling plate. And it actually comes in at 3.1 also. But it just feels heavier for some reason. But it's very substantial feeling in hand. And of course, these holes here on each side are going to be for mounting in the slots we just saw here. And we have slots of their own so that we can mount our pedal sets. Usually, I imagine this was going to fit the Logitechs, the Thrustmasters, and things like that. And if you have some kind of custom pedal, heavy-duty pedal set, you probably have to do some mod to, you know, add some profile to it or something. There's always a way to get it done, that's for sure. But yeah, overall, this feels very high quality. There will be no flex on this plate when we're pushing on it. This is very, you can tell in your hand when this is in hand that, yeah, you don't have to worry about that. So a pretty basic assembly here. But the thing is, we're going to have to put this part on first onto the rails, because as you might have remembered when I was talking about the rail assembly here, I had it on the cockpit, the motion cockpit part before, but I had to take it back off because it was covering the access holes that I needed to be able to get to from underneath to attach to this part. It's just one of those things, you know, that it's just the way this thing is designed. So yeah, we have to do it that way. Now, another thing is once I have this part of the pedal tray attached to that frame, I won't be able to push this back far enough to access the same access holes to mount my wheelbase mount. So I'm going to have to mount the wheelbase mount first, slide it in, and then come back and mount this. And I'm going to do that on this table here so I can kind of hang things off the edge and access those windows on the bottom. And you'll see what I'm talking about when I actually do that. So yeah, pretty simple really how this is working. Again, no height adjustment. I wish we had something there for height, but yeah, you could probably build something on this to get it high enough, which is the case with a lot of these type of cockpits. So what we'll do next is, yeah, we'll get the rails up here, and show you how we assemble these pieces on. Again, the wheelbase is going to have to go on first, and then we'll put this on, but we'll see how all that goes together. So we'll go ahead and get the wheelbase assembly on here first. And this is here, let me show you guys these access holes one more time. And you can see two of them right here, right? And there's the slot on the top. And we use the access holes to hold those rectangular nuts in position while we put a bolt in, right? But once you have this sitting, and this is the top, obviously, where the slot is. Once we have this sitting on the cockpit, or the base over there, this is covered up as far as being able to get up underneath it and access it, right? And that's important for one of the pieces on the wheelbase mount and all of the pieces on the pedal tray mount. So you'll see what I'm talking about once I get there. So having it off allows me to kind of hang this to the side like this, so I can get up under here when the pedal tray is on there or something else that is blocking me and hold the nut on. That's not a problem with the wheelbase. The wheelbase is pretty simple. What we do with that is, get a little closer, you can see here, it has two holes in it right here, right? And the wheelbase assembly has a slot in it. So it's very easy for that one. Only thing is, you got to get your finger in here with the nut far enough to hold it to get the actual bolt started, right? And again, these are 20mm M8 bolts. And I think I can do this one with my finger if I get back far enough on it. There we go. So I'm going to go ahead and start that one. And we're going to leave it loose, just like we would in like an aluminum profile setup. You know, so it's got some slack in it, so it's not interfering with anything when we slide that other tube in there against it. So I'll go ahead and put this one in. This one's easy to reach. Okay. So now we should be able to slide that in there without too much drama, as long as the nuts are straight. Actually, let me take this one out a little bit. There we go. And I'm putting my fingers in there, making sure these rectangular nuts are straight in there like that, not turned sideways, because then obviously our tube won't slide in there. Now we have to start the assembly, get back a little bit here, by taking the wheelbase assembly and putting it up here like this. All right. So it's going to hang off, and you can see where this tube, as I push it, is going to go right in there like that, right? And it's going to go right into those nuts that I have there. Problem is, I still need one up here on front. But now it's easy for me to access this window because the pedal tray is not here. And once the pedal tray is on there, I would not be able to get to this because it needs to be in front of this, not behind it. So it's just one of those, it's a sequence kind of thing that you have to pay attention to. So what I'm going to do is pull this back towards the end, kind of shove the whole thing back a little bit because it's going to be out of balance by moving this weight. And I'll come up to where the window is that you saw before and put my finger in there, again, holding the nut in there, getting it lined up in another M8 bolt with the washer. Easy enough. Okay. In this one, I don't have to worry about hanging down too low. I just have to have it loose enough to move. And now we'll come back and slide this in just like this. As long as everything is straight, we should be able to get in there. And there it goes. All right, good. Make sure everything's loose. So now, actually this one's a little bit too tight now. Okay, there we go. So now this also gives us an adjustment as far as in and out, right? And I also have this flange over here that we have to worry about. So we can't forget that one, right? See this flange over here that needs to be connected to this slot. So again, it's all about sequence. So now I have to take this back over here, get to where the window is, inside of here, right? Take another one of these rectangular nuts and see if I can hold it up there. And then I'm going to slide this back to it. If I can do this. Yeah, I think I can get it in there. There it goes. And then take another 20mm M8 bolt and get that one going. Like that. So now we're correct on our sequence. And we can take this thing around again and slide it home. As long as I can see one of my nuts in there got twisted. And that's not a good thing when you're trying to shove the tube in there. So let's go ahead and there we go. So now it's going in and there we have it. Now we're done. But again, this is adding weight to this whole assembly, and I'm going to have to pick this whole thing up to get it over there. And I'm going to kind of snug this up before I pick it up and take it over there, because I don't want it sliding all around, obviously, while I'm trying to lift it and put it over there. So what we'll do next is we'll come back and show you what I mean about that pedal tray assembly and why we had to do this in this particular sequence. So we're almost there. Now we're going to put this bottom tray onto the frame itself. Now, as I said before, we have to do it this way because of the, a certain sequence, because we're going to lose access to our holes, these holes in here, so we can hold these nuts in and get them attached once we have it sitting on the cockpit. So if this was sitting on the cockpit or the motion base over there already, I would not be able to get to this, because this guy, we have 3 holes here. Let me just go show you that again in case you missed it. 3 holes there that mount. We're only going to use the front and the rear holes though, because the instructions, that's what it calls for. And I feel like that's enough. I mean, we could put another one in here, but yeah, I think that's plenty. But you can see once I put this on top of here, there's no way to get under this thing. You've got the lip over here, right? This angled lip going down, so that kills the access. And if I pushed it far enough forward to get to it, then these holes, see how far this will go. It's probably not going to help me, is it? As far as it goes. But anyway, if I push this far enough to get my finger in here, the hole's way up here. So there's no way for me to get it back on there. So there's only one way to do this, and that's having it hanging off like this and being able to get into those holes we just saw that now are being covered up with my nut and hold it there and look straight down while I pull this back and start getting things mounted. So that's what we're going to do now. I'm going to go ahead and, again, we're using these M20, or rather not M20s, they're 20 millimeter long M8 socket head cap bolts, and of course the usual rectangular nuts that we've been using throughout. So what I'm going to do is kind of go in here with my finger and hold this up here in the window, up in the groove, just like we normally been doing. And now I'm going to slide this all the way back, trying to keep it from falling off the edge until I can get to that. And then I'll take my bolt and go ahead and put it in like that. So it's real easy when we can do it this way. Now I have to go over and get the other one done too by going under this way. Again, holding it up there so I can see it, and then get that one started. So now I have to push it forward until the other holes come into where those nuts can go into the windows under here as access holes, and get those going. So I have 2 more of these over here, and we're just going to do the exact same thing. Do one over here first. Put my finger on it. This goes pretty quick actually when you're doing it like this. So yeah, this is definitely the only way to get this done. And then I get this one in. Very easy when you do it like this. But yeah, this is what I call, or what is known as, an interference part. So it interferes with us being able to do other things once we have it installed. So now it's installed here, I can go ahead and just kind of snug this up a little bit so it won't move on me. And now I'm at a point where I can come in and install this on the actual rig itself. Now what I'll have to do is, again, slide it out to the front and get a nut on the bottom inside of here, because now we're going to be taking, I'm going to get one of these rectangular nuts inside of here in the window, because now we have a hole on the bottom that the bolt's going to come up through the bottom frame, those 80 mil by 80 mil tubes over there, and I'll be able to come in and catch that nut and then tighten it down. We do one here, we do one here, and at the rear down here, we also do one on each side, right? So you kind of have to maneuver this around to where you can do it. In fact, once I have it in there, I'll probably just go ahead and slide this up far enough to where I can get the nut in, and then I can come back underneath with the bolt. But we'll see how that works once I get it over here, or over there. But right now we're good to go as far as lifting this up and setting it back on the actual motion platform top. Now the last thing we're going to put on the cockpit assembly is going to be these side mount seat brackets. Okay, and you can see it's got a little logo water jetted in there as the T1000, which is what this cockpit is, and we have one for each side. Now we also have some offset holes here, so we can go, which is kind of nice for a wider seat or a narrower seat. And the seat that I got with this cockpit is actually the ProSimu's own seat, and we'll take a look at that in a minute too. What I like also is there's lots of adjustments here, right? So we should be able to dial in a very good seating position, I would think. And this is a very low cockpit to begin with. This cockpit assembly we're putting on top of the motion platform. So yeah, it's going to be low already. And I like it low. We want it pretty low because I like to have my heels in line with my butt as it's sitting in the seat to get a nice ergonomic position. But we'll see how that works out once we get them on. And we'll be putting them in the rails that we've already seen in that cockpit frame assembly with these rectangular nuts just like we did before, and putting in an 20 millimeter M8 socket head cap bolt. And that's going to allow us, once this is attached, to slide these back and forth for adjustment. Because remember, the steering wheel wheelbase assembly doesn't slide that much, but this will definitely give us a lot of room for sliding to get good reach on the steering wheel. And then of course we can adjust the pedal plate, and I've got a feeling pretty much anybody will be able to dial in a pretty good position on this unless you're really, really tall. But again, once we get everything mounted over there and get a seat put on, we'll be able to tell for sure. Now we can take a look at the final piece we'll be installing in this part 1 of the 2-part review for this ProSimu T1000 M5 unit, and that will be the ProSimu seat that came with it. Of course, you can see we have a lot of ProSimu stitching on the seats here, which actually looks rather nice, and it has a very soft feel to the fabric. I'm not sure what this is, but it does definitely feel pretty soft. And the cushioning feels firm up here in the front, and in the bottom it actually feels a little less firm, right? So it seems like it might be a comfortable seat. I don't see any really noticeable defects that stick out to me as far as the stitching, loose threads, that kind of thing. And it is red, in case you didn't notice. Yeah, if red is your favorite color, this is definitely the seat for you because it's got red all over it. And actually it doesn't matter to me, black or red. I really don't care that much about the colors so much, as long as it's a comfortable seat. And I'll bring this in a little bit closer so we can get a closer view of some of the features of the seat. And one thing that stuck out to me is this right here. This is actually a pocket. See, it has a nice stitch piece up there, and you can actually stick something in this. I don't know, stick your gloves, your phone, or whatever you want to put in there. So yeah, that's the first time I've actually seen this. So and it looks like they put it in a good place to where it's not going to be worn on getting in and out. Yeah, I mean, of course time will tell, but again, a nice red accent there and some red stitching here. I don't know how well that's going to show up because it is just a single stitch that's going all the way around the seat, and it goes up in here. We have some ventilated type of accents here. These are not like any kind of real tough material or anything. It's just the same material that's down here in the bottom of the seat. And all this is Velcroed in. You can see go back a little bit, the red stitching for the accents here. And again, we have the ProSimu in there. And we have some quilting on the bottom. See that? Some nice quilting. That's a nice accent. That's actually, I haven't seen this on a seat before. I'm sure others have it, but this is the first one that I've seen that has that on there. And of course, this is all Velcro attached. We have, this comes out as one piece, as you might imagine. And that quilting goes, let's go ahead and put this over here, all the way through the depth of the seat. Oop, get the front of it there, I'll drop it. And you can see we also have, very nice, we've got the access for the 5-point or 6-point part of our harness if we're going to run one of those. So yeah, and it's Velcro here. So this is just like a real racing seat that you can replace the cover on this if you need to. The back part is a dense material, or a dense foam rather, with the same kind of soft material. It's hard for me to convey what the material feels like, but it's actually pretty cushy, I think. And it's kind of like what you find on the Sparcos and stuff, but not quite. It just doesn't have that same stiff feel to it. This is a little bit softer, I think. Again, this is the kind of thing it's hard to describe. It's got these pieces on the side here, the headrest. So if you're racing on a track, pulling a lot of G's, it's the helmet cushion up there for your helmet. That I'm not a big fan of these in sim racing. I mean run any seat you want to, I always say, but me personally, this kind of getting in and out is something to get past. So I kind of rather not have these, but again, either way. And let's see, anything else we want to see here? That's about it. It is a nice stiff, it feels stiff, the tub here. Yeah, I'm kind of impressed with this seat actually, because a lot of seats that come with cockpits I've seen before, they have a lot of flex in them, but this actually feels like a very stiff tub here. And yeah, I'm actually kind of impressed by this. But then again, we won't know just how stiff it is until I'm in the cockpit and, you know, putting heavy pressure on the brake pedal. But overall, yeah, this is actually a nice looking seat, I think. And you can get this in different, and I think it comes in I know it comes in black. I forget what the other color is, but yeah, I got the red. Pretty bright. So yeah, not much else to see here. We have the standard pattern on the side here for connecting this to our side brackets that we've already mounted over there on the cockpit. And yeah, so what we'll do next is go ahead and get it mounted on the cockpit, come back and see how that looks. So the seat is mounted, and it wasn't that hard to get it done. Did have to make sure our seat brackets on the side were parallel with each other so that everything went in like it's supposed to. I have this set back, as you can see. Come over here and take another look at it. All the way at the bottom and at the second hole from the top on the front part. So it's got a good lean back, I think. And I've already sat in it, and actually it's a pretty comfortable seat. It's a little bit wider than I would like personally if I was going to go buy a seat. But yeah, this was going to let some of my bigger friends get in and try this cockpit, which is a good thing. But yeah, it's pretty comfortable actually. But then again, we don't know for sure until I've actually put some hours in the driver's position, actually driving everything. And it looks like I'm going to be able to get the wheel deck at the right angle and height, because remember, we can actually raise and lower this through those slots down there. So we have some movement on the Z-axis, so we can come up and down, and of course we can actually tilt it to our own needs. Pedal tray is flat, and if you look, it's hard to tell from here. Maybe if I go around the other way and get a better angle of it. There we go. So the pedal tray is flat right now, and I'm probably going to leave that, depending on the pedal set that I use, of course, because you can see the back of the seat there is pretty low compared to where my heels would be resting on that plate. And this is pretty close to a good GT position right out of the box. And I really like that, because so many cockpits, you're in a truck driver position and you really can't do much about it except build a huge platform on your pedal tray and try to get the pedals up higher. But right now, this is looking pretty good, and it's feeling pretty good when I was sitting in it. So far I am pleased. So this will be, yeah, this is going to be the end of our first part, or the build as I'm calling it, of the T1000 M5 Prosemu motion cockpit. And we'll just go ahead and get to the final thoughts next. Final thoughts on the build process for the Prosemu T1000 M5 motion system. Now, this is a very long video, even when compared to my usual lengthy reviews. This directly reflects the build complexity of this platform. The metal beams and other bits that make up this platform are what I would consider to be rather heavy duty. And this is a good thing, as they will be required to bear some very stressful loads from the motion it will be delivering. All the parts have a nice black powder coat finish to them. The welds on the larger load-bearing beams have a nice thick look to them, and of course creating a good durability expectation here. Actually, the assembly is a bit more involved than, say, a profile style platform. There are many bolts and nuts to cinch down here, and some of the attachment points require some creativity to be employed to get them to properly locate for fixing. Some areas require the proper assembly sequence to ensure you don't cover up a bolt or nut access hole. So slow and steady was the rule for this build. For the yaw elements of this platform, Prosemu has chosen to go with transfer bearings, which I think is a very good choice. And the fact that they are used in all four corners of the moving base ensures the SCN6 actuator has a very smooth and easy to move platform. Much better solution than a single pivot bearing used in many of the other yaw capable cockpits. The top frame assembly is the heaviest part of this unit. I managed to get it assembled and installed by myself, but I would recommend having a friend help you out with this. Of course, the heft is directly proportionate to the forces it will be subject to from the four 150mm travel actuators. Speaking of which, these are Prosemu proprietary actuators, and they call them the PRS 200s. They deliver what I would consider some very good specs at 280mm per second of travel, capable of up to 2 Gs of acceleration, and that up to 193 kilograms. I can't wait to get them up and running for testing. This unit came with a T1000 cockpit assembly, with wheelbase, shifter, and pedal tray assemblies that seem to be sturdy enough to keep a driver happy. But of course, we'll have to wait and see how it does once I start driving it. The seat that can be ordered with the T1000 also seems to have a nice and stiff shell, with a good-looking soft cover with adequate padding. Of course, when it comes to a seat for sim racing, you really don't know how it's going to work out for you until you actually use it. Overall, the build went as smoothly as I could have expected. It did take me a bit to get it done, but now that it's finished, it does give me confidence that it will be able to deliver a good motion experience. But more on that in the setup video. In that production, I'll be going through the steps to bring the motion system online and tuning it to my personal preferences. I'm Barry Rowland. Thanks again for watching the Sim Racing Garage channel. Don't forget to hit the subscribe button. And if you would like to help support what I do here at the SRG, visit my website at simracinggarage.com.